functions. I'm going to talk about find mean from data stream. Median is nothing but what is a middle value, or like it can be a single or average of the middle two value. That is the mean. And if you know what is heap and how the heap works, you can skip this chapter and move to the next chapter. I will talk about heap. Heap is nothing but an array which will be storing the data in a very proper binary format, so that anytime if you want, you can able to access the largest or smallest based on the heap tree structure. If we have a larger heap, you'll have always first element will be the larger element, and if it is a smaller heap, it will have the smallest element. So how it works is, you can keep on adding the element. It will try to do that sorting, and then it is to keep it in a heap structure. And when you try to take it, right, you can remove it and you can fetch it. That's extract. At that time, it will give you the largest value. Like for example, input here is 15, 27, 9, 3. When you add, it will store in a format, and then when you try to remove, it will extract and review the data like 30, and then 20 you will be able to extract, and then 15 you can able to extract, and then 9 and then 7. It will be a sorted one. So here, the example is when you have this array, we will be adding one by one. So like for example, you will add 15, it will be added, and then you will add 20, and when you add 20, you will be adding at the last element. Last element means in the array, it will be the last position. So you will know the last nodes, leaf node position you will be adding. So you will be add it. After you add it, you will do the heapify. That is nothing but make sure that parent should be the larger value than the child node. That is a condition. So you just swap it till it make it as a buffer. And then when you add 7, you will be adding that array at the last, and then you will check whether it's smaller than parent, then it's all right. And then similarly, you will keep on adding the element. See, if you add 9, it is smaller than 9, so it is fine. And also here also, you can see it's not satisfying. 30 is greater than 15. So this we need to be swap, and then again it will be a for loop. Again, until the condition gets satisfied, you need to swap. That parent should be larger than the child. So once you've done that 15 and 30, you will see the imbalance between 30 and 20. So again, you will swap, and then once you found, it will be done. So this is that adding operation. So this code I will show. So here, this is the heap array. So once you try to add a number, you will know the count of the array. That is the last heap where you are adding at the last, right? Here 20 and here 7, 9. That is that portion of it. So we will be, you can able to get the parent of it by -1 divided by 2. So this is the thing. You will get the parent, and then you will compare. If it is not satisfying the condition, you will swap them, and then till root node of the tree. So root node is be at the 0 position of the array. So we will be checking that condition, making sure that swap has been done, and that parent is always the greater. So this is the addition. You can able to refer it. Now I will talk about extract function. So this is the add function, and then extract function is almost similar to this while loop. Here in extract, what is the key thing is already we will have the maximum value and the first position. We will delete it, and then we will put the last value in the array in the top, and then we will do the again heapify it, all the elements till it gets sorted. You can see that in the code. We will get the last value and we will remove it in that position, and then we will start this loop. You can see here whether this condition is to check whether the node has left and right, both the things. If it is having both, we will take the maximum value for the swap with that last value, or else we will take the only, if it is a single value, we will take only left, and then we will be swapping. So like for example, once that is removed, we will remove the last, that 15, and we will put it in the top, and then we will check which is having the 20 or 7 is having the max value, and then if since 20 is having, we will compare with 15. Since it's not sorted, so we will be swapping it to heapify, and then we will get this as the value. So this will be the array, the next thing, and then we will be again we will be removing 20. Here again, we will, once we remove the 20, we will take the last value from the array and then swap it, and then again check the heapify, and that's how it works. We will be getting the sorted value 30, 20, and then here after heapify we will get 15, and then 9, and then 7. This is how heap works. Now you can able to see to fetch the first value. This is the heap code, and this is where we are sending the operator. We have a 2 different heap tree here for this median. One is the maximum value and another one is the minimum value. The sorting will be, your maximum value will be storing the value in 30, 20, something like that, and minimum will be in the opposite, like where will be like 7, 9, something like that will be stored. And we should make sure both the heap should have the same count, or here in this example we are making sure maximum heap count is greater than minimum heap or equal to it, like greater than 1. So here when we try to add any element, as we told, max heap will be 1 greater than mini heap. So we are making sure max heap is the starting guy. So if max heap itself is having 0, we will add it into the max heap, or else the newly adding count, right, element, if it is really huger than the max heap or larger value, then we will be adding it into the max heap, or else we will be adding into the mini heap. So once we add it in the max heap or in mini heap, we need to make sure these counts are being stabilized. So we will be making sure their count, if max heap count is greater than the mini plus 1, then what we do, we extract an element from the max heap and then we'll add it to the mini heap. Similarly here, if count is mismatching and at any point of execution they can find the median. So if max heap count is greater than like it's like 1 is greater, right, then it will be a odd in count, so we'll be taking the max heap larger value, or else we will be try to take a dividend of both the peak. So how this works, you guys get able to get it, right? So whenever it we are dividing into half, so here 1 half the max heap will be having a larger then all the elements in the max heap will be larger than the mini heap. So this is the main conditional lab. Yeah, then we can able to fetch it. So now I'm going to talk about the key points. Key points are we need to create a comparator in the heap where it will be getting the operation done. So here we are passing the operation, and then how addition in the heap works is whenever we add an element, we'll be adding at the leaf element, which is at the last at the array, and then we'll be sorting it out with the parent of it. So the parent formula is minus 1 divided by 2. So once we user was adding it the last, and then he'll be checking the condition, and then he'll make sure that EV5 is done. Like for example, here the T is been added at the last, we'll be checking the condition, we'll be swapping it. And similarly in the extract, when something is being extracted, once we remove it, and then we will replace it the last one with the top. So both the place we will be here will be addition will be adding at the last, and then EP5 from the last, and then here we will replace the last guy in the top, and then we'll do the EP5. So this is the condition. So here we'll make sure that one is great. We'll make all the heap, like max heap will be, all the elements will be larger than the mini heap. Either both of the count should be equal, or only max heap will be one count more than the by one count.